Hello, today's lesson is about variation functions. Let's get started. Our objective today is learning how to solve problems that involve direct, inverse, joint, or combined variations. The vocabulary words you need to be looking out for are these 5. I've highlighted them in the text, and I'm also going to make sure that you know when we come across them so that you can get them down and understand exactly what it is we're talking about. The first one, direct variation. We also have constant of variation, joint variations, inverse variations, and combined variations. All right, let's get started. All right, here's your first vocabulary term, direct variation. A direct variation is a relationship between two variables that can be written in the form y equals kx, where k does not equal 0. We've actually seen this before in this formula here, y equals mx plus b. Hopefully you all remember what this is the formula for. Now comes the second vocabulary term. It's the constant of variation. In the above example, the direct variation formula, k is our constant of variation. It's the constant that determines how the two variables are directly related to each other. All right. So which variable in the slope-intercept form is the constant of variation? Well, what is being multiplied by x? It's the letter m. So the slope is our constant of variation. Let me show you how I got that. Alright, here's my first example. Say we're given the equation y equals 10x. Well, what relates the y to the x? What is our k, our constant of variation? Well, we find that very simply. We just look at what's multiplied by the x. 10 times x, so our k equals 10. You can see the same thing over here where I've got a table showing x and y values. K is my constant of variation. Negative 1 times 10 is a negative 10. 0 times 10 is 0. Notice that no matter what my value of x is, my y value is 10 times its size. That is one way of being able to determine what my value of k is. Now let me show you what the graph of a direct variation looks like. Direct variation should always be a line. And so you notice as my x gets bigger, what happens to my y value? It also gets bigger. The only time you would see something direct that doesn't look like this would be if the k is negative, and then all that would do would be to change the slope. Right, so there's direct variation. Well, let's look at some problems with direct variation. Alright, here's the first one. We're given that y varies directly as x. That phrase right there is telling us how they're related. It also says y equals 27 when x equals 6. And they want us to write and graph the direct variation function. Alright, well, the first step is easy. Write down the generic direct variation function. Y equals k times x. Now take the information they were given and substitute it in. It said y is 27 when x is 6. We still don't know what k is. But now we can solve for k and figure out that k equals 4.5. Alright, well, we're almost done. The only thing we need left in order to graph it is to plug k in to the equation. Y equals 4.5x. Well, that's an equation we can graph, and I'll show you that on the next slide. Alright, here it is. You all know how to graph an equation. They have y equals 4.5x The y-intercept is 0, and the slope is 4.5. Now how do we check that? Well, we can take the numbers they gave us in the problem, plug them back in. If it works out, then we did it the right way, and we did. Alright, well that's our direct variations. Alright, now, this one is a problem I want you to practice for class. So I will give you the answer in class when we go over this. Here are the steps involved. And to be honest, these are the steps you're going to use in every single problem we cover today. There might be a little variation in manipulating things, but on the whole, this is it. So first thing, determine what type of variation you have. So far, we've only learned direct, but we're going to learn the others. Write the generic formula, plug in the numbers they give you, and then solve for k. Take that value for k and plug it back into the generic formula, and then you can either graph the equation or you can solve for a different value. No matter what, these are the steps you want to use. Alright, so there you got it. Make sure you get that down, and we're going to keep going. Alright, here's your third vocabulary term. Joint variation is a relationship among three variables that can be written in the form y equals kxz, where k is the constant of variation. For the equation y equals kxz, y varies jointly as x and z. So that's what you're looking for. You're looking for that phrase, y varies jointly. But this is exactly like our direct variation, except this time you've got one more variable. And just so you're familiar with these terms, the phrases y varies directly as x or y is directly proportional to x mean the exact same thing. Alright, here's a joint variation problem. The volume V of a cone varies jointly as the area of the base B and the height h. And the volume equals 12 pi cubic feet when B equals 9 pi square feet and h is 4 feet. Alright, find B when the volume is 24 pi cubic feet and h is 9 feet. Alright, a lot of numbers, a lot of information there. Let's just take it slowly. First step, we're going to write it in its generic form. Volume equals k times our base times our height. We're not using x, y, and z, but it's meaning the exact same thing. Alright, now we're going to plug in the numbers they gave us. 12 pi for our volume, 9 pi for the base, 4 for the height. Solve for k, we get k equals 1/3. Plug that back into the equation. Using 1/3 for k, now we've got volume equals 1/3 base times height. Get the other numbers they gave us. 24 pi equals 1/3 the base times 9. Solve for b. We get b equals 8 pi, so the base is 8 pi square feet. Right? Just like we did the last one, except this time they give us one more variable. But all it means is they need to give us one more piece of information. So we've got it. Alright, this one is for y'all. Try and work this one out as well. We'll go over this when we get to class. So I'll give you a second to pause and get it.